Solving trig equations. So this is the last topic, or the last part of the topic, wave functions. So we're going to be looking at questions like this. So a typical question might be something like solve, so solve equation 5 cos x plus 12 sin x, which is when it's equal to 13 and k is greater than 0 and a is between 0 and 360. Okay, so they don't even give us the trig equation to use to expand out. So we need to think of our own. Well, I'm going to stick to cos x minus a because it's the one that is it's not going to change the sign of anything, and it's quite easy because all the cos terms are together and all the sine terms are together. Okay, so taking my coefficients, boom, boom. I'm just going to go through this fairly quickly because I think by now we should be familiar with what's going on. 5, 12, then k. Well, we know this is 5, 12, 13 triangle, so it's going to be 13. Okay, sorry if I'm skipping steps, but I just want to get on to the fun part. And then alpha is going to be equal to tan minus 1, 12 over 5, which is equal to 67.4. Cool, and let's have a look at the quadrants. Okay, so they're both positive, so they're both going to be in there. So a equals 67.4. So this becomes 13 cos x minus 67.4. Okay, remember, the question is asking us for when it's equal to 13, right? So when it's equal to 13. Okay, so before this is too tricky to solve, right? So what we've done is simplified it into a simpler form, and now from here we can manipulate it. So what we're going to do is move this 13 over, or divide both sides by 13. So this becomes cos x minus 67.4 equal to 13 over 13, which is equal to 1. So what we're going to do is now take the inverse cosine of both sides, okay? But before we do that, we need to think about this this value here. Okay? You think about this value here. Is it positive or negative, right? Again, back to our cast diagram again. So we need to think where this is going to be positive for where it's going to lie for this cos. So if cos of 1, it's going to be positive in the first quadrant and positive in the fourth quadrant. Okay, we'll see why this is important in a sec. So you want to take the inverse cos of 1. So x minus 67.4 equals cos 1, and we all know that the inverse cos of 1 from our cos diagram is, big drum roll, not really, equals 0 and 360 degrees. Okay, so it's 1 there and it's 1 there. Okay, so the reason, and you could also think, okay, well that makes sense, that agrees, because the first quadrant is here. Okay, that's the 4 quadrants. Okay, so it's positive there and it's positive there, just as we suspected. Okay, so let's figure out what x is going to be. X is just going to be equal to 0 plus 67.4 and 360 plus 67.4. So x is equal to 67.4 and 427.4. Okay, and remember here, okay, it's only asking between 0 and 360, so this is not a valid solution. So our final answer is this. So x equals 67.4, and that's when you'll get a value of 13. Okay, so what does that look like actually on a graph? So I'll sketch this for you. Here is a sketch of the graph 13 cos x minus 67.4 between 0 and 360. Okay, so it follows this point here. And where does it equal 13, right? It equals 13 here. That's the only place that this graph equals 13 in the entire range of the entire interval, okay? So at this point here, 67.4, and that. So does that make sense? So basically, these kind of questions are asking, when does this line equal some value? So if it was 10, it would have been there and there. If it had been -5, it would be here and here. But for this question, they're asking us for 13. So we're going to do some more examples, and hopefully everything becomes a little bit more clear.